Hello and a warm welcome to everyone joining us today. I hope you're having a fantastic day so far. Today we'll be discussing some of the modern IT demands of educational institutions in the digital economy, how DDI solutions can address them effectively. In this webinar, we'll explore how a DDI solution is revolutionary in providing high availability, elastic scalability, holistic control, centralized visibility, and advanced security when built on a solid foundation of policy-driven management and automation. Very quick introduction. I'm your host, Akshara GJ, product expert from ManageEngine. I collaborate closely with the marketing teams for ManageEngine, DDI Central, and Cloud DNS. A big part of what I do is talk about the critical network services like DNS, DHCP, and IPAM. I'm here to share insights on how DDI solutions can significantly optimize educational network infrastructures. As for the agenda today, we'll start by examining the current IT landscape and the unique demands of educational institutions in maintaining robust and efficient networks. Next, we'll discuss how achieving comprehensive visibility and control can significantly improve network management and performance across campus networks. We'll then explore the crucial role network segmentation plays in ensuring security, manageability, and efficiency within educational environments. Also, we'll look at how an integrated IPAM driven by policy automation can revolutionize the way networks are managed and maintained. Moving on, we'll see how your network services remain available and resilient with multiple automatic failover setups. Following that, we'll explore how the onboarding process for new devices is streamlined, making it quick and hassle-free with zero-touch provisioning. We'll explore how real-time analytics can help you monitor your network, identify potential security threats, and manage resource availability effectively. Lastly, we'll dive into comprehensive strategies to defend against cyber threats, ensuring the security of your campus networks. Look at the figures here. According to Critical Start, the second half of 2023 alone witnessed a staggering 84% of cyber incidents in K-12 schools due to ransomware attacks. This stark figure is a testament to the cunning strategies of cybercriminals who exploit network vulnerabilities to encrypt critical data and demand ransom. A close second, phishing campaigns and vulnerability exploitation constitute 30 and 29% of incidents respectively. The data speaks volumes. Without a fortified network infrastructure, educational institutions remain at high risk for disruptive cyber activities that can severely impact the learning process and the safety of student and institutional data. Let's now focus on the demands of modern education networks, which are crucial to ensure efficient, secure, and scalable operations. First, scalable, flexible, and autonomous deployments. Modern education networks must support rapid scaling and flexible deployment options to accommodate growing number of devices and users. Autonomous deployments help reduce the administrative burden and improve overall efficiency. Advanced trend capture and capacity planning. The device per capita of every university student ranges between 5 to 10 devices, whereas for a school student, it is 3 to 5 devices. To stay ahead of the curve, educational institutions need advanced tools to capture usage trends and perform accurate capacity planning. This ensures that the network can handle peak loads and future growth without disruptions. Structured IP address plan with complete network visibility. The networks in schools and universities are characterized by diverse logical and physical departments. This diversity implies highly segmented large number of diverse subnets. A well-structured IP address plan is essential for managing a complex network. Complete visibility into the network helps administrators monitor and manage resources effectively, reducing downtime and improving performance. IPv6 addressing and routing. As the number of connected devices continues to explosively grow, campus networks demand IPv6 addressing as it offers a vast address space and improved routing efficiency, ensuring that the educational institutions' future network expansions is always accommodated. Defense in depth security. Mobility offers users great flexibility, but it also makes infrastructures more vulnerable by exposing campus internal networks by giving access to non-controlled device and users. Therefore, security is paramount, especially in educational environments where personal data is at risk. A defense in depth approach provides multiple layers of security, protecting the network from a wide range of threats and ensuring the safety of student and institutional data. Addressing these demands with a comprehensive strategy and right tools will enable educational institutions to build robust, efficient, and secure network infrastructures that support their academic missions and future growth. Let's take a deep look into the image on screen. This image illustrates how educational institutions interconnect their distributed networks across multiple campus facilities using a centralized core network. This network structure is typically made up of multiple LANs, VLANs, public and private cloud infrastructures, data centers that link to a wider network or WAN. As you can see, this complex setup interconnects primary, middle, and high school network facilities, all while enabling students to connect to one of these facilities from their homes through a centralized core network. This typically involves a high-performance private WAN serving as the backbone. The backbone is often established using dedicated IP/MPLS routes or an optical core that interconnects all parts of the network with transmission devices. The main challenge in this network infrastructure is converging all these facilities under a common IP infrastructure. How do we achieve IP convergence? A network infrastructure like this needs a convergent solution like DDI. Let's explore what DDI is. DDI is a comprehensive network management solution that unifies three core network services: DNS, DHCP, and IPAM. It enables you to take complete control and gain holistic as well as deeper visibility into the configurations of these three services. With a DDI solution, you can easily define and manage scopes, dynamically lease IP addresses to hosts, set up custom DHCP fingerprinting policies, manage DNS zones, views, and records, set up DNS security policies, analyze DNS query traffic, review audit logs, manage dual stack IP address inventories of your network, all through a single window. What if I told you that this one window solution can also serve as a single point of management for all your internal and remote campus sites? Yes, with the DDI solution, you can easily manage the DNS, DHCP, and IPAM configurations of each remote campus facility already connected to the main campus network using advanced technologies like SD-WANs, IP/MPLS core via VPN, or even dark fiber. This way, the campus network administrators can holistically view and centrally manage the core network services of different remote campus facilities associated with the main campus network, all from a single window. As you can see in the image over here, we have the DDI solution managing the primary, middle school, and the high school's DNS and DHCP clusters. Along with it, it also manages the mission critical zones managed by external or third party vendors like Cloudflare, AWS, Microsoft Azure, and Google Cloud. All this from one single window. So once it discovers all your clusters of DNS and DHCP, it enables you to visualize all these configurations from one single window. When you visualize, you can easily control and configure the settings and analyze the process and all the properties, and then you can generate reports. So it's a wholesome solution that gives you complete control and holistic yet granular visibility over your core network services across different clusters or different distributed sites. So let's see how this is possible with ManageEngine's own DDI solution, DDI Central. So in DDI Central, you can manage each campus network facility as a separate cluster, as you can see on the screen. Each cluster comes with its internalized IPAM and its own IP address plan and can be managed independently of other clusters. All you have to do is add your DNS and DHCP servers to each cluster and discover their configurations and manage them from a unified window. You can just choose the cluster of your choice and monitor the health and performance of its core services in real time. So this is how you can seamlessly scale as your campus networks facilities grow using DDI Central. Let's now focus on a crucial defensive strategy in network management, network segmentation. We'll see how segmenting your campus network is not just an operational tactic, but a strategic necessity in today's cybersecurity landscape. Segmentation provides detailed visibility into each segment, its inventory, objectives, and policies in the form of DHCP options and tighter control over the configurations. This granularity is critical for identifying and responding to suspicious activities quickly. Network segmentation guides your network administrators where to look at in the event of an incident or capacity exhaustion. In the event of a security breach, segmentation helps contain the impact to a limited area, preventing the spread of harmful effects across the entire network. Advanced scope monitoring with defined segments provides network administrators with a visual breakdown of IP addresses within the scope based on their availability status, capacity thresholds, ensuring effective capacity planning and resource optimization. Custom policies for address pools within subnets allow for specific security and access policies tailored to the needs of different host groups within the same department, enhancing both security and operational efficiency. Segmentation also offers flexible configuration options for each scope, which means networks can be tailored to meet specific functional requirements or regulatory compliance needs. By grouping different subnets into shared networks, we can club multiple non-consecutive and unrelated scopes to treat them as a single entity to apply custom policies collectively. You can reduce the scope of compliance by reporting the audits of only those segments to the regulators instead of the whole network. Let's see how the scopes are managed in DDI Central. So we have the DHCP scope manager, which organizes the scopes as subnets, supernets, shared network, and VLANs. Client class has special structures that helps you identify and group the clients that join your network. It is the subnets, shared network, and VLAN that are actually the building blocks of your network. Supernets are used just for simplifying your network administration practices. So it's just the subnet and shared network, and we also have DHCP reservations. So as you can see, you have different subnets configured here, and you can see the pool ranges and the usage percentage of each subnet. So let's see how you can configure them in DDI Central. So in DDI Central, to configure subnet, you need to provide the network address, its network prefix, and you have to select the DHCP server that is going to draw IP addresses from this subnet and assign it to a global or under a shared network. So shared networks are nothing but a group of subnets bunched together, and you treat them as a single entity and apply custom policies using DHCP options and custom options collectively. And here, while defining a subnet, you'll have to define the pool data, and within the pool data, you can apply granular policies to this specific pool. So you can have multiple pools within the subnet with different policies coupled with it. You can also assign different DHCP options and custom options at each level, like at each subnet level, shared network, or if you're assigning a DHCP reservation for a host, you'll have to mention the MAC address of the host and give it a fixed IP address, and you can assign them under a global level or under a subnet or under a shared network or a host group. So host groups are nothing but a group of hosts together, and they can apply collective policies to them. So this is how the scopes are organized in DDI Central. So when you have segmented your scopes into subnets, shared networks, and other topological elements here, you can easily monitor these scopes. So when you have defined your subnets, you can get into each subnet and monitor the IP addresses within the subnet. As you can see, there's a donut plot over here, which provides a visual breakdown of the number of IP addresses in the subnet according to their availability status. These visual snapshots helps a network administrator for effective capacity planning and forecast threshold issues. On this slide, we see a simplified example of how network segmentation is achieved using DNS domain views. We'll walk through the process step by step, highlighting the distinction between internal and external views for zones under the domain name zilkeruniversity.com. So let's see what DNS views first. DNS views are special features through which you can implement network segmentation using DNS servers. It enhances protection against potential threats by customizing DNS responses, enforcing distinct security policies, and controls access for different user groups and network segments within your institution. We see a client initiate a query for the zone admissions.zilkeruniversity.com under the domain name zilkeruniversity.com. This request is sent to the DNS server to resolve the domain name into an IP address. Upon receiving the query, the DNS server first checks the client's IP against the internal view match list. The internal view match list contains only IP addresses of registered students and faculty members who are involved in guiding the admission processes. In this scenario, the client IP is not found in the internal view list. Since the client IP is missing in internal view, the DNS server then checks the external view. The external view has no such IP restrictions and resolves queries for any client IP. This view is used to provide a version of admissions.zilker.com, zilkeruniversity.com that only offers generic information about admissions. The DNS server confirms that the query for zilkeruniversity.com should be handled under the external view. It locates the requested zone under the domain name zilkeruniversity.com and directs the client to the appropriate resource. Finally, the DNS server sends the appropriate response back to the client, and the client then proceeds to access the resource. You can view the query analytics for each view, each zone, and overall domains defined in your DNS servers from the query analytics page. So you can see the hourly query load for your domains or zones, and then you can see the IP addresses that's been accessing your domains or zones, and you can see the total query count distribution for each IP accessing your zones. So at the bottom section, you can find the different types of records queried under a particular domain name, and you can see the visual distribution of it over here. DDI Central captures audit trails of every action executed on each and every object managed by the DNS and DHCP servers. You can choose the relevant subnets or zones and report the audits of only those segments to the regulators. This saves time and reduces costs compared to operating full network audits. Let's see how DDI Central implements auto failover setups for DNS and DHCP servers. In DDI Central, for the DHCP servers, while configuring a subnet, you can add one primary and add as many secondary DHCP servers you want. In case the primary DHCP server fails, the secondary server comes to the fore and handles the traffic. If you want these servers to split the load, and you can enter the relevant value in the split field A value of 128 here indicates 50-50 load balancing, actively involving both primary and secondary servers to handle the DHCP traffic. For the DNS servers, which while configuring a domain name, you can add multiple primary DNS servers for the domain. Subsequently, DDI Central also accepts a list of multiple secondary servers to facilitate reliable access to resources across the campus network. With the DDI solution in place, data from all the three core network services are not only collected but also correlated and analyzed in one central hub. So in DDI Central, IPAM serves as the centralized and contextualized network source of truth that maps upstream relationships among the core services. As you can see in the image here, behind the lease history of a particular IP, you get to see how it is captured and correlated rich IP metadata like DNS records, DHCP lease information, IP address allocations of various hosts within the network. This unified approach allows for a holistic view of network operations, enabling campus network admins to make timely and informed decisions based on the comprehensive data analysis. This information aids in quickly troubleshooting network issues, optimizing resource allocation, and maintaining network stability. These three core services, DNS, DHCP, and IPAM, in sync with each other, DDI serves as a sophisticated automation hub as it becomes easy to set up end-to-end automation involving these services. So here are some of the key processes that can be automated using a DDI solution. Using DHCP server, you can automatically assign IP addresses to hosts on the network. This enhances the efficiency of network resource management and ensures that the IP addresses are reclaimed and reused appropriately, reducing wastage and preventing address exhaustion. The dynamic DNS feature updates the DNS records automatically when an IP address changes, ensuring that the network resources are always accessible via their host names. This is crucial in campus settings where device mobility and configuration changes are frequent, necessitating real-time updates. DDI Solutions automatically detect and resolve IP conflicts and maintain an updated IP address inventory, ensuring reliable connectivity and preventing downtime in campus operations. Scheduled creation of DHCP scopes and DNS records allow network administrators to go on a schedule it and forget it mode, enabling them to plan and implement network expansions or updates at predetermined times for maintaining uninterrupted services during non-operational hours. The IoT or Internet of Things that you see on screen is so intricately woven into modern campus networks. Previously, devices were beyond the network's tracking capabilities, but now these devices are IP enabled and can be tracked and provisioned automatically without manual intervention. As illustrated in the diagram here, the IoT ecosystem is vast and interconnected, adding more complexity to the campus networks. These fleet of devices require custom policies, and it would not be wise to manage them in a separate address space given their dependency and connectivity with other devices and users associated with them in the network. To address this, we programmed the DHCP server coupled with the TFTP server to track and provision all devices, not just IoT, even including legacy or along with host machines, critical devices, and all your bring your own devices without any manual intervention. This converges all the IP-enabled devices in your organization, each requiring custom policies under a common cohesive IP plan and interconnects them for increased productivity. Program your DHCP server to recognize these devices by extracting device details using customized named DHCP policies without isolating them into separate IP address spaces within the network. These policies enforce specific DHCP configurations based on various criteria and provide greater control over how DHCP services are delivered to different types of clients, ensuring that each client or group of clients receive appropriate network settings. So let's see how you can achieve zero-touch provisioning of IoT devices using PXE configurations or pre-boot execution environment configurations in DDI Central. With the PXE configurations, the DHCP server does all the heavy lifting in provisioning boot files, configuration files, or other supplementary files as soon as an IoT device connects to the network. This can include lightweight operating systems, specific security updates, and customized applications designed for minimal resource consumption and rapid boot times. Using PXE configurations, the DHCP server directs the IoT devices to the TFTP server in your network. TFTP server ensures that these files are centrally managed and deployed, significantly simplifying the process of updating and maintaining a large fleet of devices scattered across multiple locations. As you can see on the screen, we've created a client class that is programmed to recognize devices based on their vendor profile. In the conditional statement over here, we've specified if the device belongs to a specific type of architecture using an architecture code, it receives a certain file path. If you see below in the DHCP options section configured with this option called Next Server, the DHCP server directs the devices that match the criteria to a TFTP server with the following IP address. All this can be automated by a DHCP server for hundreds and thousands of IoT devices as soon as they are plugged into your network without any manual intervention. This is actually a one-time configuration. You don't have to repeat it for every set of new devices joining your network. Configure it once with these instructions in place. Every time a new IoT device is plugged into your network, the targeted configurations would be applied for that device. Now let's dive into the security strategies implemented using DDI Solutions. The first one being DNS Firewall. As DNS is the first point of contact across external networks, the DNS Firewall constitutes the network's first line of defense. Following a layered approach, it places strategic defenses against unwanted intrusions. It actively blocks malicious activity using domain blocking and mitigates ongoing attacks with its response rate limiting feature. So let's see how DNS Firewall works. Let's consider a scenario where an educator from your institution, after using a public free Wi-Fi at a cafe or an airport, unknowingly gets his or her system infected by a malware. Upon connecting to your institution's private network, the malware covertly accesses malicious sites. DDI Central easily manages such situations with its DNS firewall. This firewall maintains a blacklist comprising a recognized collection of undesirable domains. Before the resolver can provide the actual IP address, it checks the domains against this blacklist. If there is a match on the blacklist, the resolver does not proceed to fetch the real IP address from the external authoritative DNS server. Instead of connecting to the malicious site, the user is redirected to a safety page, just like the one shown here. So let's see how domain blocking is implemented in DDI Central. All you have to do is mention each undesirable domain that you would like to block. And if you would like to block all the subdomains associated with the domain name, you have to just check this block subdomains checkbox. And if you'd like to include this under a certain category, you have to add a particular category, or you can include the already the list of categories available. And the main part here is you'll have to give a redirection IP. If you fail to give a redirection IP, whenever a user from your network tries to access this block domain, the page will be loading indefinitely, and then the browser messages will be displayed saying the pages are not accessible. So you can add the domains one by one, or you can import them in bulk as a CSV file and then save the configurations. And that's how easily you can block domains using DNS Firewall. And if you want to see who in your network is accessing such malicious sites, the DNS analytics page in DDI Central also displays the query analytics for every blocked domain accessed via the resolvers of your network. Here you can see who accessed what type of record pertaining to the block zone, under which IP, and specific details about their identity like their host names and the time of access. This way, the admin can quickly identify the host violating such network security policies. The network admin will also be notified via emails whenever a user tries to access such blocked domains. Also, DDI Central gives an overview of the list of IP addresses trying to reach the said blocked domains and a visual snapshot of the same to identify the major actors involved in the Security Violation Act. We see that the phishing and variant type of attacks are very common in educational network infrastructures. So we implement sender policy framework or SPF that works by adding a TXT record to the DNS settings of a domain. This record specifies which servers are authorized to send email from that domain. When an email is received, the recipient server checks the SPF record of the sender's domain to confirm that the server sending the message is allowed to send mail on behalf of the domain. The domain keys identified mail or the DKIM lookups is another email authentication protocol that helps verify the authenticity of an email message. Unlike SPF, which verifies the sending server's authorization, DKIM verifies the email's content's integrity. It does so by adding a digital signature to the email header, which the recipient server can verify. DKIM works by adding a digital signature. This signature is generated through a private key that only the sending server knows. The signature is added to the email header along with a public key that the recipient server can use to verify the signature's authenticity. When the recipient server receives the email, it checks the DKIM signature by using the public key in the email header to decrypt the signature. If the signature matches the email content, the email is considered authentic. DKIM helps the receiver to confirm that the message has not been altered or tampered during the transfer. This is because the digital signature is calculated based on the email message's content. If any part of the email message changes, the digital signature will become invalid and email will be rejected. And then we have domain-based message authentication, reporting, and conformance, DMARC policies. So DMARC works by adding a text record, TXT record, to a domain's DNS settings, specifying how to handle failed SPF and DKIM checks. It checks if the domain in the from header aligns with the domains in the DKIM and SPF records. If they don't align, the email may be spoofed and should be rejected or marked as spam. When an email is received, the recipient server checks the SPF and DKIM records for authenticity. If either fails, the email is marked as spam or rejected based on the recipient's email server's policies. If the email passes these checks, the server looks for a DMARC policy in the sender's DNS records to determine how to handle the email if it fails the DMARC check. You can check whether an email has passed SPF, DKIM, and DMARC checks by looking at the email's headers. Here's how you do it. Open the email in your email client, look for the email's headers, which are usually hidden by default, find the authentication results header, check the values of SPF, DKIM, and DMARC fields to see if the email has passed the checks. If an email fails any of the authentication checks, it may be marked as spam or rejected outright. Let's dissect a common cyber attack scenario involving a botnet and discuss the defensive strategies that can be employed using a DDI solution. At the core, we have a botnet command center targeting a particular victim network in your campus network. It keeps sending instructions to compromised endpoints called botnets. These botnets then execute the attack by sending malicious queries to the DNS servers using the IP address of the victim. This is known as IP spoofing. The DNS servers in your campus network, unaware of the deception, respond to these queries. However, due to the nature of the attack, these responses are not just simple replies. They are massively amplified, meaning a small query triggers a large response. The final target of this onslaught is the victim network in your campus facility. The amplified responses flood the victim's network, potentially overwhelming it with data and causing significant disruption. This type of attack is known as distributed denial of service or DDoS attack. These threats can be instantly identified using DDI Central's query analytics tool that visually charts unusual spikes in hourly traffic, indicating a DDoS attack in progress. To mitigate the DDoS attacks, DNS servers can be configured to limit the response rate to any individual IP address. This way, it prevents the DNS servers from being used as amplifiers in DDoS attacks. The response rate limiting is a DNS security feature that intelligently regulates response throttling to mitigate the impact of DNS amplification attacks, ensuring uninterrupted access for legitimate clients and upholding a well-balanced approach to security. When a DNS server starts receiving similar type of queries for the same IP, the DNS server with response rate limiter configured checks the rate of the request coming from this particular IP. The rate limiter's job is to determine whether the frequency of the request exceeds predefined thresholds, which are set to prevent abuse and to manage server load effectively. If the rate limit is exceeded, the server will send a throttle response back to the client. However, if the rate of the request is within the acceptable limits, the DNS server will proceed to send the appropriate DNS response to the client. So let's see how response rate limiting is implemented in DDI Central. This feature allows administrators to set various parameters that control different aspects of DNS response behavior. The RRL feature does not just limit the number of identical responses per second from a single IP address or a subnet, but also limits the number of all kinds of responses, error responses, DNS referral responses, specific types of DNS responses per second. You can also define how broadly rate limiting is applied across IP address ranges, enables you to specify the trusted clients that you would like to exempt from rate limiting. By configuring these options, administrators can significantly reduce the impact of DNS-based amplification attacks, ensuring a more secure and a reliable network. Segmenting a network into scopes, you isolate each segment from the rest of the network. This limits the potential impact of a security breach, as attackers have access to only a portion of the network they have penetrated into, rather than the entire network infrastructure. Segmenting the scopes into subnets and VLANs help contain the damage by isolating the affected segment, allowing administrators to more effectively control the spread and mitigate risks. Subnetting also reduces the network-wide threats by quarantining compromised areas and hindering unauthorized lateral movement within the network. Let's get into a use case: learning from homes, bridging the digital divide in classrooms using DDI Central. Meet Jake, a middle school student who needs to access his school's live online classes from home. We need to create a more secure, efficient, and effective online learning environment for students like Jake. While it's cheaper to conduct classes via public platforms like Zoom and other video conferencing services, these solutions have a significant limitations when it comes to hands-on management and control over the learning environment. Here are the key challenges we face. So, absorbing students into campus networks rather than having them on public IP. It's crucial to integrate students into the secure campus network rather than having them on public IPs. This ensures better control, security, and access to campus resources. The second challenge, fostering real-time high-density connections and collaborations among students and educators. To create a seamless and interactive learning experience, we need to support real-time high-density connections. This allows for effective collaborations between students and educators, exactly mimicking the in-person classroom environment. The third challenge, enforcing security policies on each connection. Security is a key factor, especially when students are accessing the network from various locations using the internet. Enforcing security policies on each connection ensures that the data and communication remain protected, safeguarding both students' and institutions' information. So what's the solution here? To overcome the challenges, Jake's school implements a private wide area network that connects all its campuses and provides secure access to network resources. With the rise in remote learning, the school extends its network to students at home using DHCP authentication over an IP MPLS core augmented with VPN technology. This setup ensures that the students have secure, reliable access to educational resources as if they were on campus. The DHCP servers are set up with special authentication mechanisms using DHCP fingerprinting policies to ensure that only school authorized devices can obtain IP addresses. VPN gateways are deployed at key points within the network to handle incoming VPN connections. DHCP authentication ensures that only authorized devices can connect, while VPN provides secure encrypted communication. Each student is provided with VPN client software and configuration details, including credentials and server addresses. The VPN client is installed on the student's home device, which can be a tablet or a laptop. When a student at home wants to connect to the school's network, they launch the VPN client. The VPN client establishes a secure connection to the school's VPN gateway using encrypted tunnels, ensuring data privacy and security. Once the VPN connection is established, the student's device sends a DHCP request to obtain an IP address. The DHCP server verifies the device credentials, example like MAC addresses, user credentials, against its client class policies. Upon successful authentication, the DHCP server assigns an IP address from a predefined pool and then the relevant DNS record, enabling the device to communicate on the school's remote network. With a secure IP address assigned, students like Jake can access network resources directly from their devices as if they were on campus. This includes access to the school's intranet, educational portals, digital libraries, and other resources facilitating seamless remote learning. On the other hand, the school's IT department can manage and monitor network access centrally, ensuring consistent policy enforcement. Now, how do we implement this in DDI Central? First, we create a client class on the DHCP server of the remote classroom 6, just like the one you can see on screen. Let's have a look at the configurations. We see for the match type, the substring option is chosen to help tell the DHCP servers search for a specific sequence of characters within the client's DHCP messages. The offset field is used to designate where this search should begin within the DHCP message. Since we want the search to begin from the very first character, we've entered the value 1 for the field. For the length field, we've given the value 17, which corresponds to the length of a MAC address. Enter hardware in the match string field, guiding the DHCP server to recognize and extract the hardware address from the packet. Since our goal is to match specific MAC addresses, each student's MAC address has been added as match value. Now this client class must be associated with appropriate subnets within the campus facilities network. So this way, the DHCP server, following the client class policies, permits only devices with those specific MAC addresses to connect and collaborate over the remote campus network. As we conclude today's webinar, let's focus on a key insight. DNS, DHCP, and IPAM are the cornerstones of network connectivity and operations. Integrating these into a full-stack DDI management solution not only addresses critical network challenges, but also future-proofs your network. A full-stack DDI solution consolidates all essential tools into a single interface, streamlining network administration and enhancing efficiency. While some institutions use freeware or open source DNS and DHCP server softwares or manage networks with spreadsheets, these approaches often lack the robustness needed for complex configurations. Some deploy IPAM solutions that just cooperate with DNS and DHCP servers, unaware of the hidden costs and burdens. A full stack DDI management solution eliminates these costs and frees up your admins from routine tasks, allowing seamless management across distributed sites. DDI solutions harmonize security, management, and operational efficiency, safeguarding educational networks from cyber threats. As cyber threats evolve, DDI solutions' importance in campus networks will only keep growing, making it a crucial component of digital infrastructure. Embracing a DDI solution is not just a technological investment, but a commitment to a safe and secure future of education, fostering an environment where security, efficiency, and flexibility support the primary mission, education. So we've come to the end of the session. Thank you for taking the time to be part of this webinar. Right after this session, you'll be directed to our downloads page where you can start your 30-day free trial today. We also have a live interactive demo set up and running for you to explore and play around with. If you have any queries, please shoot us a mail at DDI Central, DDI support@ManageEngine.com. And this is your host, Akshara, signing off. Thank you.